Hello, welcome to part 4 of exponents. In this part we're going to discuss about negative exponents and how you make negative exponents into positive and the process in which you do that. Because often what one is asked is to put everything in terms of positive exponents, so we want to figure out what happens when you get a negative exponent. How do you make that positive? We want to rewrite expressions without negative exponents. The first thing we do is we write the reciprocal of the base and then change the exponent to a positive to keep it with the original base. Now, of course, one may ask, what does this mean? Well, this is what it means. If you have a negative exponent, what it means is that essentially it's 1 over the base to the positive power. And in this case, the power here, -1, its positive power would be 1, so it's 1 over x to the first power, or 1 over x. And of course you can do the reverse. If you have a negative exponent on the bottom here, x to the -1, you can bring that upstairs and put that just simply as x to the +1, or just x. So let's look at a few examples. So for example, if we have b to the -7, what we want to do is we want to write the reciprocal of it and its positive exponents. So that means we'll write a 1 over b to the +7. In number 28, here we'll use this rule because we have 1 over y to the -8. So we'll bring the y upstairs and then change it to a positive exponent, giving us y to the 8. So in 27, we used this rule here, and in 28, we used this rule here. Evaluating negative exponents. So we want to divide and write without negative exponents. So let's look at a few of these. So in number 29, we have 4 to the -3. So since we have 4 to the -3, we want to put that as a positive, so we're going to write the reciprocal and then its positive exponent. That means we're going to write it 1 over 4 to the +3. And then, of course, evaluating that, 4 times 4 is 16, and then 16 times 4 is 64. In number 30, here we have that situation that we had before, that if we have 5 minus 7, well, 5 minus 7 using our quotient rule will give us a negative exponent of y to the -2. So there we have that, y to the -2. But now we have to convert that y to the -2 to a positive exponent. We have to take the reciprocal 1 over y, and then 2 we have. In number 31, we have something a bit more complicated. So what I'm going to do is I'm going to work this out on the whiteboard in detail. In example number 31, we have n to the 4th. In example number 31, we have m to the 4th, n to the -5 over p to the -2. Now we see that we have negative exponents for the n to the -5 and the p to the -2, and this we do not want. We want to make them into positive exponents. So here we're going to use our negative exponent rules. So the m to the 4th is okay, and we keep that the same. But the p to the -2, we're going to use the rule 1 over x to the -y
is equal to x to the y. So I'm going to move the p up here and make it p squared. Similarly, I'm going to take the n to the negative 5, and I'm going to use the negative exponent rule that says x to the negative y is equal to 1 over xy. So that means that I'm going to bring the n to the negative 5 to the bottom and make that to the positive 5.
In summarizing number 31, we have m to the fourth. I put this downstairs as n to the fifth power, and I brought p to the negative 2 upstairs as p squared. In number 32, we have 2 over 5, and the whole thing is to negative 3. Well, I'm going to work this out on the whiteboard also.
In example number 32, I have 2 over 5 to the negative 3. Now here I have the negative exponent outside of a bracket, and inside the bracket is a quotient. Well, this is the same thing because we have to make the negative 3 affect both the top and the bottom. So this is the same thing as 2 to the negative 3 and 5 to the negative 3. And again, we're going to use our negative exponent rules. So recall that x to the negative y is equal to 1 over x to the y, and that 1 over x to the negative y is equal to x to the y. So this is the same thing as saying we're going to take the 2 to the negative 3 and move that downstairs. So that's going to be equal to 1 over 2 to the 3, and then the x to the 5 to the negative 3, I'm going to move that upstairs and make that 5 to the third. And I'll just put a 1 as a place mark to show you exactly what's going on. And then I'm going to do 1 times 5 to the third. So I have 5 to the third, and then 2 to the third times 1, and then I get 2 to the third. But if you notice, it's really the same thing as flipping over the stuff inside the bracket and then making that positive. So as a shortcut, what I can do, I can start out 2 to the fifth to the negative 3, and that would be the same thing as 5 over 2 to the positive 3. Either way you look at it, it's fine, because in the end, we will get 5 to the third, 2 to the third, and in both cases, we have 5 to the third, and that's going to be equal to 125, and then 2 to the third, that's going to be equal to 2 to the third, that's going to be equal to 8. Similarly here, we have 5 to the third because that's 5 times 5 times 5, and that'll be 125. And then at the bottom here, we will get 2 to the third, which is 2 times 2 times 2, which is 8. So either way you look at it, you'll get the same answer.
In summarizing 32, we end up with, to get everything positive, it turns out that we get 5 cubed on the top and 2 cubed on the bottom, and that will give us 125 over 8. For number 33, we have 3a to the fourth over 4, and this whole thing is put to the negative 2 power. So let me work that out on the whiteboard to show you how this could be done.
We're given 3 a to the fourth power divided by 4. And this whole thing is to the negative 2 power. Now, the first way I can do this is just multiply everything inside the bracket by negative 2. So I get 3 to the negative 2, a to the 4 times negative 2 because it's a power. And then I have 4 to the negative 2. And this is equal to 3 to the negative 2. A to the 4 times negative 2 is to the negative 8. And then 4 to the negative 2. But I have all these negative powers. So now I have to use my negative quotient rule to get them to be positive powers. So that means that the 3 to the negative 2 will have to go downstairs and become 3 squared. The a to the negative 8 will have to go downstairs and become a to the 8th. And the 4 to the negative 2 will have to go upstairs and become 4 squared. And now I just work it all out. So the top becomes 16 and 3 squared is 9. And then I get a to the 8th. A to the 8th. Now the other way I can do it with a little bit of shortcut, seeing that I have a quotient inside the bracket and I have a negative exponent on the outside. I have a to the 4th, 4, and that's going to be equal to, to the negative 2, and now what I can do is say 4 over 3a to the 4th, and now it's to a positive 2. And then I could say 4 squared over 3 squared a to the 4th times 2. And again, I'll get on the top 16. And this will be 9, and this will be a to the 8th. So either way, whether I do it by bringing the exponent inside the bracket or by flipping the quotient over, will give me the same answer.
Summarizing 33, whatever technique you use, you'll end up with all positive exponents. So this way I did it all positive exponents by turning it upside down and then bringing the 2 inside. And then working it out explicitly, so I get 16 over 9a to the 8th. In number 34, I have this, and again, what I'm going to do is I'm going to work this particular example out on the whiteboard to show you how it could be done.
In example number 34, we have 3a to the 6th, b to the negative 4 over 2, c to the negative 2. And all of this is to the 2nd power. Well, my strategy here, and of course you can just multiply it in and work it out the long way, but I'm going to make a strategy here. And I see I have these negative powers inside my bracket. So I want to get rid of the negative powers inside here. So I'm going to use my negative quotient rule to do this. So that means I'm going to bring my b to the negative 4 downstairs and make that b to the positive 4. And then I'm going to take my c to the negative 2, move that upstairs, and make that c to the positive 2. So now let me do that. So I'll get 3 a to the 6th, which I do not touch. I'll bring my c to the -2 upstairs and make that positive c to the positive 2 power. I'll leave my 2 alone here, but I will bring my b downstairs and make that to the positive 4 power, and then I will square it. And now I will proceed to organize and bring everything in. So I now have 3 squared a to the 6 times 2, c to the 2 times 2, all over 2 squared b to the 4 times 2. So now I'll just work out the rest of it. So 3 squared is 9. A, 6 times 2. Well, 6 times 2 is 12. So that's a to the 12. C to the 2 times 2. Well, 2 times 2 is 4. And then on the bottom, I have 2 squared. Well, that'll give me 4. And then b is the 4 times 2, and that'll give me b to the 8th. And since all these bases are different, and there's nothing I can simplify this with, so then I am done, and this is as simplified as I could make this particular expression.
Summarizing 34, we have here everything in this case was put in terms of its positive exponents inside the brackets. So the b was put downstairs as b to the 4th. The c, -2, was put upstairs as c squared. And then everything was multiplied through using the power rule to get our final answer. In example number 35, we have 10x cubed, and this is to the -3rd power. So here again, I'm going to work this out on the whiteboard.
In example number 35, I have 10 to the x cubed to the -3. Now here again, I'm going to use my negative exponent rule, and that will tell me that one way to look at it is 10 to the 3, x to the 3 times -3, and that'll give me 10 to the -3, x to the -9, but because these are negatives, that means I'll have to put 1 over 10 to the 3rd here times 1 over x to the 9 here. And 10 to the 3rd, well, that's 1 over 1,000 times 1 over x to the 9. And then I'll just put it together and write 1,000 x to the 9. Another way to do this, as I showed before, is to recognize, again with the exponent rules, 10 to the x cubed, -3, that I can just make that positive by recognizing that this really is something over 1, so that if I turn it over, I'll get 10x cubed, and this will be to the 3rd, and then I will continue. So 1 to the 3rd is just 1, 10 to the 3rd, x to the 3 times 3. So here again, I'll get 1,000 x to the 9th. So again, either way you look at it, you'll still be using the negative quotient rules, and you'll get the same answer.
Summarizing example number 35, in order for me to get it as a positive exponent, I had to put 1 over 10x to the third, and then here I have the positive 3 rather than a negative 3, and then worked it out to get rid of the exponent using the power rule, where 1 to the third power is 1, and then 10 to the third power is 1,000, and of course using the power rule right here, where we have x, 3 times 3 will give me x to the ninth. In number 36, I have this to the negative 2 power, and I'm going to work this out on the whiteboard.
In example number 36, we have 9a to the fourth, b to the sixth, divided by c to the third. And that's to the negative 2 power. And we see that inside the bracket here, they're all the exponents are positive, so we don't really have to do anything. So all we have to do is either multiply the negative 2 in and then use our quotient rules, or we can just realize that we can flip it over and change this to a positive, and that's another way of using the quotient rule. So I'll do just changing it by flipping over. So we're going to get c to the third over 9a to the fourth, b to the sixth, to the second power. So you see, this is a negative 2, this is a positive 2, but you see now the c cubed is on top rather than bottom, and this part is on the bottom rather than the top, but now the exponent outside the bracket is positive. So now I'm going to multiply the 2 inside the bracket. So I'm going to go c to the 3 times 2 over 9 squared, a to the 4 times 2, b to the 6 times 2, and that's going to be equal to c, 3 times 2 is 6, so it'll be c to the 6, and that's going to be divided by 9 squared. That will give me 81. And then 4 times 2 is 8, so it's a to the 8th. And then b, 2 times 6 is 12, so that'll give me b to the 12th. There's no more simplification I can do since all these bases are different, and I am now finished simplifying this particular example.
In summarizing example number 36, I ended up here. I just flipped it over inside the bracket and turned this one into a positive exponent. As I said, this was one of the techniques, and then worked it through to get my final answer. In number 37, I have here a lot of negative exponents inside the bracket, and I also have a negative exponent outside the bracket. So let us work this out on the whiteboard to see how we could simplify this particular expression.
In example number 37, we have 7a to the negative 6, b to the negative 2, all divided by 8c squared, and the whole thing is to the negative 2 power. Now, of course, there are different ways we can go about this. One way is to multiply in the negative 2 first, and that will give us 7 to the negative 2, a to the negative 6, negative 2, b to the negative 2, negative 2, divided by 8 to the negative 2, c to the negative 2 times negative 2. And there we have 7 to the negative 2. A negative 6 times negative 2 will give us positive 12. B to the negative 2 to the negative 2 will give us B to the 4th. And then on the bottom here, we have 8 to the negative 2, and then C to the negative 2 times negative 2 is negative 4. So now we have to start getting rid of those negative signs using our negative quotient rule. So we'll have to bring the 7 downstairs. So we'll have 7 squared. The A to the 12, well, that's okay. The B to the 4th, that's okay. Now let's look down here. Well, we have that A, 8 to the negative 2. Well, that's not good. We'll have to bring that upstairs, and 8 squared. And then we have that C to the negative 4. So we're going to have to bring that upstairs and make that C to the positive 4. And then, of course, we'll just finish up by taking the squares. 8 squared is 64. And we have A to the 12th, B to the 4th, C to the 4th, all over 49. Now, of course, the other way we can do that is to flip this inside the bracket first and change this to a positive sign and then continue. So let's do it in a different order. Now, the other way I can do 37, I can actually approach it in this way. I can have 7 A to the negative 6, B to the negative 2, all over 8 C squared, and there we have to the negative 2. So what I'll do is I'll just change the position inside the quotient and make this positive. So what that means is that I'll have 8c squared over 7a to the negative 6, b to the negative 2, and that'll be positive. Notice how these still remain negative inside there. The only thing I did was change this negative sign to positive by flipping this over. Then I again will use my power rule, and I will go 8 squared c 2 times 2 divided by 7 squared a to the negative 6 times 2 b to the negative 2 times 2, and that I will get 8 squared c to the 4th over 7 squared. Well, as you see, we have 6 times 2, negative 6 times 2, and that will give us negative 12. So that's a to the negative 12. And then we have b to the negative 2 times 2, and that's b to the negative 4. Now we have to use our negative quotient rules to bring that upstairs. So that means we have 8 squared c to the 4th, a to the 12th, b to the 4th, and that will be over 7 squared. And I'll just rearrange it and finish it off a bit. So I have 64, a to the 12th, b to the 4th, c to the 4th, and this whole thing is over 49. And this is the same as we got in the other approach. So either approach is fine. Some strategies are shorter, some strategies are longer. Whatever works for you would be fine.
Summarizing 37. Here what I did is that I got rid of all the negative exponents inside the bracket. In this particular way of doing it, as I showed, there are different ways of approaching this. And then I did change the sign of the power and multiplied in using the power rule. In example number 38, we have this inside the bracket and it's just squared. So what I'm going to do is work this out on the whiteboard.
In example number 38, we have negative 6m to the 4th n to the negative 7 divided by 5m squared n to the 15th, all this to the positive 2 power. So since we have this quotient inside here, and it's to the positive 2 power, we don't even have to worry about flipping it over or doing anything fancy because we have a positive quotient. But if we notice, we have negative powers inside there. But also note we have a negative 6. But a negative 6 is just a negative number, so we leave that alone. So the only thing we have to do is, based on our quotient rule, is to move our negative n to the negative 7 to the bottom and make that 1 over n to the positive 7, and then deal with our power outside the bracket. So here's what we do. Negative 6m to the 4th. Nothing on the bottom here is negative, over 5m squared n 15. And then I'm going to bring down the n and make that to the positive 7. And now I will square it. So now I'll just organize everything. So I'll put my numbers in my first bracket, n6 over 5 squared. And then I'll put my m's, m to the 4th over m squared, and I'll square that. And then finally, I'll put my n's, and remember it's over 1 because this is on the bottom, and therefore there's a 1 over there, times 1. So that's going to be n to the 15, n to the 7th squared. So now I'll work that through. So that's going to be equal to negative 6 squared over 5 squared. And then my m's, so I'm going to bring my 2 in there. So I'm going to have here m to the 4th times 2 over m squared times 2. And then here I will have, well, 1 times 2, 1 to the 2 power is just 1. So that will remain the same. And then the bottom, I'll use my product rule, n to the 15 times 2, n to the 7 times 2. So here on top, I will get negative times a negative 6 is a positive 36. Divided by 5 squared is 25. Then I will get m to the 4 times 2, so that's going to be m to the 8th divided by m to the 4th. So I'll just put in brackets to keep it separated. And then I will get 1 over n to the 30th, because 15 times 2 is 30. And then n to the 7 times 2, well, that's 14. And then I will continue using my various rules. So here I have 36 divided by 25, and then I use my quotient rule, 8 minus 4, and then here I'll just keep the 1 on top, and I'll just use my product rule here, n to the 30 plus 14, and continue on. 36 over 25, so n to the 8 minus 4, so that's going to be m to the 4, and then on the bottom times 1 over n to the 44, and I'll put it all together in one quotient situation. 36 m to the 4th over 25 n to the 44. And now I have simplified this very complicated expression to this not as complicated expression in example number 28.
Summarizing what we did on the whiteboard. So in this case, I made sure what I did here is I made sure I got rid of all the negative exponents inside the bracket and then worked it out till I got my final answer. In example number 39, we have this, and it's to a negative 4th power. So what I'm going to do is work it out on the whiteboard.
In example number 39, we have 3y to the negative 3 divided by 2x squared, and this whole thing is to the negative 4. So what I'm going to do is I'm going to get rid of the negative number inside the bracket. So here, so as you recall, our quotient rule will say that we have y to the negative 3, and that is going to be 1 over y to the 3. So I'm going to now rewrite this as 3 over 2x squared y cubed, and this whole thing is to the negative 4th power. Now, as I said before, if you see a negative power outside of a quotient, that gives you permission to just flip it over and make it positive. So I'm just going to do it that way. Of course, there are other ways to do it, and all those other ways are fine so long as you get the correct answer. So I'm going to go 2x squared y cubed all over 3, and I'll do this to the 4th power. And now I'm going to continue simplifying as usual. So I have 2 to the 3rd 2 over 3, I mean, to the 4th power. And I have my x's. And I have, so here I have x squared times 4. And then I have my y to the 3rd times 4. And then I'll finish it up. 2 to the 4th over 3 to the 4th. And that's going to give me x to the, and then x to the 8th, y to the 12th. And then I'll work this out. And it turns out 2 to the 4th. Well, 2 to the 4th is 2 times 2 times 2 times 2. So that's 4. 4. So that's 16. So I'm going to get here 16 on top. And then on the bottom, I'll do 3 times 3 times 3 times 3. So here 3 times 3 is 9. 3 times 3 is 9. And 9, and that's going to be 81. So on the bottom, I get 81. And then x to the 8th, y to the 12th. And now I am finished simplifying this particular example. Notice all positive exponents. There are no negative exponents because recall we do not want any negative exponents.
Summarizing example number 39, what I did was here is I got rid of the negative exponents inside the bracket, and then I flipped it over and worked it out. In number 40, we have this. Now notice here how the bracket, this is to the negative 2, and it's only this. It's not the entire quotient. And this bottom one, where this one is to negative 4. So you have to look at it a little bit different than we did here, where this bracket covers everything, and this bracket only covers the top to the negative 2 power, and this bracket only covers the bottom to the negative 4 power. So let's look at how we deal with something like this on the whiteboard.
In example number 40, we have x squared, y to the negative 3, z to the negative 2, and this whole thing is to the negative 2 power. Then on the bottom, we have x cubed, y squared, z to the negative 1, and this whole thing is to the negative 4th power. Now, notice that the bracketed negative 2 and the bracketed negative 4 don't have a quotient inside. This bracket, everything's multiplication. This bracket, everything's multiplication. So we can't just flip it over. We really have to work out everything. And actually, the first thing we're going to do in this particular one is I'm going to now I can bring in the negative 2, or I can switch places, but I have to be very careful when I switch places. So I can't just do it the way I did a regular quotient. I have to be careful of these powers. So what I can do is bring this whole thing upstairs and this whole thing downstairs using my negative quotient, my negative power quotient rules. So what I can do now is say x cubed y squared z negative 1, and then bring that to the 4th power. Notice how I brought that upstairs. And then on the bottom, I can go x squared y to the negative 3, z to the negative 2, and this is to the positive 2. So in a way, I flipped it over, but it's slightly different than when I do it when the whole thing or the whole expression is inside a bracket where the quotient is inside the entire bracket. So now what I'm going to do is I'm now going to use my power rules. So I'm going to get x to the 4th times 3, and then y to the 4th times 2, and then z to the negative 1 times 4. And that's what I have on top. And similarly, I'll do for the bottom. So I have x 2 times 2, because I'm bringing a positive 2 in there, and then y to the 2 times negative 3, and then z to the 2 times negative 2. And then and then I'll work out each of these, and then I'll sort out the negative signs at the end. So here I have x to the 12th, y to the 8th, z to the negative 4, divided by x to the 4, y to the negative 6, and z to the negative 4. Now I'll just organize them, and I'll do the x's, x as I've done before, and then my y's, and then my z's, so I have now, do each one separately, so I have x to the 12 minus 4, and I have y to the 8 minus 6. Notice how I'm very careful of my signings because it's a quotient. And then I have z to the 4 z to the negative 4 minus 4. So I have here 12 minus 4 is 8. And for x to the 8. And then I have y 8 plus 6. And then finally I have z negative 4 plus 4. And then I have x to the 8th, 8 plus 6 gives me 14, so that's y to the 14. And recall z, negative 4 plus 4 is 0. And remember, anything to the 0 power is 1. So that means we have x to the 8, y to the 14, and then times 1, because anything to the 0 power is 1. So there we have, we just rewrite it, x to the 8th and y to the 14th. And now we are finished simplifying this really complicated expression into something that truly is rather simple.
Summarizing example number 40. So here, as you noticed, in this case, I did the negative exponents first, taking this entire expression and putting it on the bottom, and then making it positive, and taking this entire expression here and putting it on top and making it positive. And then I continued working it out the way I would just a regular expression where this is brought to a power and this whole thing is to a power using my power rules. And then finally here I have still negative things going on, but now I can start moving things up and down between the numerator and the denominator, or I can just use my quotient rules to work that out. However you want to do it is fine. Thank you very much. I hope you enjoyed this video, and I hope this helped you understand a little bit more about working with exponents. So take care and be well. Bye.